Module 3, Lesson 12, the relationship between absolute value and order. In the last lesson we started exploring absolute value. We are going to continue that exploration and start talking about the order of numbers. I can show and explain that the order of positive numbers is the same as the order of their absolute values. So if I have a set of positive numbers and I find their absolute value and put their absolute values in order, that would be the same as if I put the positive numbers in order. I can show and explain that the order of negative numbers is the opposite order of their absolute values. So if I have negative numbers and I put them in order from least to greatest, and then I take their absolute values and put their absolute value in order from least to greatest, the order will be opposite. I can show and explain that negative numbers are always less than positive numbers. So in class we would create some integer cards, and we would have integers that range from -50 to 50, and you would have 5 negative integers, 0, and 4 positive integers. You would then trade your cards with another pair of students, and you would work on ordering these cards from least to greatest. So if you would like to do that at home, go right ahead and make your cards and put them in order. If you created your cards, you can now put your cards in order using an inequality statement. And below each integer, you would write its absolute value. So for example, and I will just do a very simple one here, I have -5 is less than -4, which is less than -3, which is less than -1, which is less than 0, which is less than 1, which is less than 2, which is less than 3. So I have my 4 negative numbers, negative integers, I've got my 3 positive integers, and I have 0. Below each of my integers, I now need to write the absolute value. The absolute value of -5 is 5. The absolute value of -4 is 4. The absolute value of -3 is 3. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. And the absolute value of 3 is 3. Circle the absolute values that are in increasing numerical order and their corresponding integers. Describe the circled values. So what we're doing is taking a look at our list here, and we're saying, where do things kind of match up? Right here I see things matching up. They're in the same order. 0, 1, 2, 3, 0, 1, 2, 3. Not only are they in the same order, but they are the same. These positive integers, 1, 2, and 3, and their absolute values, they're in the same order. Rewrite the integers that are not circled in the space below. So I have -5, -4, -3, and -1. These integers are different from the ones I circled because these are the negative integers. Their opposite value does not look the same as their absolute value. I don't think I said that the right way. Let me try again. Their value, the way they look, is not the same as their absolute value. Now that feels a little bit better. If I were to put these in order from least to greatest, I have -5 is less than -4, which is less than -3, which is less than -1. If I take their absolute values and put them in order from least to greatest, I would have 1, 3, 4, and 5. The order of their absolute values is opposite the order of the integers. So rewriting the negative integers in ascending order, -5, -4, -3, -1. Their absolute values in ascending order are 1, 3, 4, and 5. Here are the integers in order from least to greatest. Here are their absolute values in order from least to greatest. So their orders are opposite. Describe how the order of the absolute values compares to the order of the integers. It's opposite. What was last is first. What was first is last. These middle sections are reversed. We are going to draw arrows starting at the dashed line, which is 0, to represent each of the integers shown on the number line below. The arrows that correspond with 1 and 2 have been modeled for you. So they've drawn this little dashed line here to get us to 1, and they drew a little dashed line here to get us to 2, and now we need to draw a line to get us to 3, another line to get us to 4, and another line to get us to 5. And we need to do the same thing with the negative integers, starting at 0, going to -1, starting at 0, going to -2, starting at 0, going to -3, starting at 0, going to -4, starting at 0 and going to -5. As you approach 0 from the left on the number line, what is happening to the integers? Let's pause for a moment before we answer that question. Let's just do a little bit of looking at what we have created here. So which integer is represented by the longest arrow? Which one of these integers has the longest line? As I look at it, I see that the -5 and the 5 both have the same length of line because they are the farthest away from 0. Now, because their lines are the same length, what does that mean? That means they both have the same absolute value. Which of our integers that's not 0 has the shortest lines? Well, the shortest lines are 1 and -1, 1 and -1. They're the closest to 0. They're also the same distance from 0. They both have the same absolute value. Did we draw an arrow for 0? Nope, because 0 is right on top of 0. Do all of the arrows start in the same spot? Yes, they do. They all start counting from 0. If they started counting in different locations, it would be much harder for us to compare how long they are. Are all of the arrows pointing in the same direction? If I add my arrows onto the end here, do they all point the same direction? And the answer is pretty obviously no. They don't point the same direction. Positive numbers are pointing to the positive side of the number line, and the negative are pointing to the negative side of the number line. The lengths of the arrows are getting shorter as we get to 0 from the left or from the right. So if I'm coming from the left-hand side, as I get to 0, they get shorter and shorter and shorter. As I'm coming from the right-hand side, the closer I get to 0, they get shorter and shorter and shorter. That means the absolute values are decreasing the closer I get to 0. The closer I am to 0, the less the absolute value. The farther I am from 0, the greater the absolute value. As you approach 0 from the left on the number line, the integers increase, because remember, -1 is greater than -2, which is greater than -3, which is greater than -4, which is greater than -5. So as we approach 0 from the left on the number line, the integers increase, but the absolute values are decreasing because we are getting closer to 0. This means that the order of the negative integers is going to be opposite the order of their absolute values. So looking at this picture helps us see that, yes, as we come this way, they get greater, the numbers get greater, but their absolute values are decreasing the closer we get to 0. So think of a real-world example that shows why the order of negative numbers and the order of their absolute values are opposite. Pause and think about that for a moment. Can you think of a real-life example that would go along with this? Well, Alec, Benny, and Charlotte all have negative cafeteria balances. So one of them owes $3, one of them owes $4, and one of them owes $5. So the person that owes the least, if we put these in order from least to greatest, appears to be the -5, because if we put them in number line order going from least to greatest, -5 is least, then -4, and then -3. However, if we actually look at the magnitude, the amount of money owed, the absolute value, we find out that 3 is the least amount that is owed, 4 is the middle amount, and 5 is the most amount. So here we have this opposite order thing. If we just look at them as integers on the number line, it appears that this person who has the -5 has the least. However, they owe the most, so it's opposite. -5 is least, but it has the greatest magnitude, meaning he owes the most. So here is a more written explanation of what I just tried to explain out loud. So the number that represents Alec's cafeteria charge account balance is the greatest because he is the least in debt. Alec owes the least amount of money and is the closest to having a positive balance. His balance of -$3 is farthest right on the number line of the three balances. So here we have some numbers, and we are going to separate the set of numbers into positive rational numbers, negative rational numbers, and 0 in the top cells to the right. Order doesn't matter. So we're just working in this one and this one. We're not looking at absolute values yet. So I have a positive number, 2 1/10. I have a negative number, -4 1/2. I have a negative number, -6. I've got a positive number, 25 hundredths. I've got a negative number, -1 5/10. I've got a 0, which is already there. I've got a positive 3 9/10, -6 3/10, -4, 2 3/4, 3 99 hundredths, and -9 1/4. All right, so I have sorted the numbers. I've got my negative rational numbers, my positive rational numbers, and I have their absolute value. Write the absolute values of the rational numbers in the bottom cells. All right, the absolute value of -4 1/2 is 4 1/2. The absolute value of -6 is 6, 1 5/10, 6 3/10, 4, and then I've got 9 1/4, 2 1/10, 25 hundredths, 3 9/10, 2 3/4, 3 99 hundredths, and 0 of course remains as 0. we are going to order each subset of absolute values from least to greatest. So I'm looking at the absolute values now, and I want to put them in order from least to greatest. The least absolute value to the greatest absolute value. Looking at the absolute values for the negative rational numbers, the least, and of course this is a great time to pause the video and do this by yourself and then compare your work with my work. The least is 1 5/10. Next I have 4. I have 4 1/2. I have 6, 6 3/10, and 9 1/4. In order from least to greatest. Okay, positive rational numbers from least to greatest. I've got the 25/100ths. I've got the 2 1/10, 2 3/4, 3 9/10, and 3 99/100ths. So I have them in order from least to greatest. I am going to do least to greatest again, but this time I'm actually going to order the numbers, not their absolute values, but the numbers. Another good time to pause the video, try this on your own, and then compare your thinking with my thinking. Alright, so I have, and I'm thinking in my head of that number line that we looked at with the grid and the length of the arrows. Which arrows are taking me farthest from 0? So looking at these rational numbers, that negative 9 1/4 is going to take me farthest from 0 in the negative rational numbers. The next farthest is going to be 6 3/10, and then 6, negative 6, and negative 4 1/2, and negative 4, and negative 1 5/10, with 0 in the middle. Looking at the positive numbers, once again, if I'm going from least to greatest, I'm thinking about how far away am I from the 0. So if I'm going least to greatest, on the positive side, I want to be closest to 0. On the negative side, if I'm going least to greatest, I want to start with the farthest away and work my way back in, and that would give me the numbers in order from least to greatest. For the positive, I want to start as close to 0 as I can and then move away from 0 on the positive side. So I've got 25/100ths, 2 1/10, 2 3/4, 3 9/10, and 3 99/100ths. The last thing I need to do is order the whole given set of rational numbers from least to greatest. So I have the entire set all the way through. So I'm going to combine both sets of numbers. And of course it helps that we did exercise 1D because we already have them in the right order. The question is, can we copy them down? So I've got negative 9 1/4 is the least, followed by negative 6 3/10, followed by negative 6, followed by negative 4 1/2, followed by negative 4, followed by negative 1 5/10, followed by 0, followed by 25/100ths, 2 1/10, 2 3/4, 3 9/10, and 3 99/100ths. One of the big things to draw attention to or pay attention to on this particular activity is this right here. The order of the absolute values is opposite the order of the integers. When I have negative numbers, the order of the absolute value will be opposite the order of the integers. No, not even integers, rational numbers. Sorry, I said that poorly there. And it's true for integers, but it's also true for rational numbers. So the opposite orders. The absolute value of negative numbers is opposite the order of the numbers. Boy, I keep saying that. I hope that it's clicking. All right, find a set of 4 integers such that their order and the order of their absolute values are the same. So I need 4 numbers that when I put them in order from least to greatest or greatest to least, that will be the same order as their absolute value, if their absolute values in order from greatest to least or least to greatest. So pause and think about that for a minute. What if I did 4, 6, 8, and 10? They're in order from least to greatest. If I order their absolute values, it's still 4, 6, 8, and 10. So the order remains the same. The order of the integers is the same as the order of their absolute value. Find a set of 4 integers such that their order and the order of their absolute values are opposite. Go ahead, pause, and think about that. Well, what if I do -4, -6, -8, and -10? Their absolute values are 4, 6, 8, and 10. If I put them in order from least to greatest, I would actually have to reverse the order of the integers here to be least to greatest. Their absolute values are already in order from least to greatest. Find a set of 4 non-integer rational numbers. So now I have to use fractions and decimals such that their order and the order of their absolute value are the same. So I am repeating the same thing I did with A, except this time I need to do it with decimals and fractions. So what if I did 1/2, 2 3/8, 4 3/4, and 17 1/10? The absolute values of these are going to be in the exact same order. The absolute value of 1/2 is 1/2. The absolute value of 2 3/8 is 2 3/8. The absolute value of 4 3/4 is 4 3/4. The absolute value of 17 1/10 is 17 1/10. Find a set of 4 non-integer rational numbers such that their order and the order of their absolute values are opposite. So we are repeating what we did for part B, but now we are doing it as rational numbers instead of integers. So what if I have -1/2, -3/4, -7/8, and -1 2/10? So they are in order from greatest to least, right here. If I were to put their absolute values in order from greatest to least, I would write 1 2/10, 7/8, 3/4, and 1/2. Here are their absolute values in order from greatest to least, and that is opposite the rational numbers in order from greatest to least. Order all of your numbers from parts A through D in the space below. This means you should be ordering 16 numbers from least to greatest. I am going to let you do that with your own numbers. I am not going to try to drag this video out any longer. Pause, take a moment, and write them in order from least to greatest. So you would be looking at these right here, putting them in order from least to greatest. Below are the absolute values of a set of rational numbers in increasing order, so they're going from least to greatest. Can you determine the order of the rational numbers themselves? If so, explain why and write the numbers in increasing order. If not, explain why. So they give us a set of numbers and they say, can you tell me what order their rational numbers were? So these are absolute value. They found the absolute value of some numbers and they put these absolute values in order from least to greatest. And they come up to you and say, hey, I got this list of absolute values. I've got them in order from least to greatest. Can you tell me the order of the rational numbers? Pause and think about that for a second. Your brain probably screams at you, yeah, I can do that, I can do that. But pause and think about that for a second. It's only possible if the rational numbers were positive numbers. And we don't know if the rational numbers were positive numbers. So no, this isn't really possible, because the rational numbers could have been negative numbers, in which case they would be in one order. If they were positive numbers, they would be in a different order. So if you are told that the numbers above represent the absolute values of positive rational numbers, could we figure out the order of the rational numbers? And at this point, your brain is probably screaming at you, oh, yes, I could. So if these are the absolute values and the original numbers, the rational numbers, were positive, then the order is going to be exactly the same. Because we know that the order of rational numbers and the order of their absolute values is the same. You might be remembering that ICANN statement. Now, if we're told that the numbers above represent absolute values of negative rational numbers, could we find the order of the rational numbers? And the answer is yes, we could. If we knew that these are the absolute values of negative numbers, we would write them as the negative rational numbers, but we would put the order in reverse, because we know that the order of negative numbers and their absolute values are opposite. So if we were putting them in order, we would, from least to greatest, we'd put negative 9 and 9/10, negative 7, negative 4 and 3/10, negative 4, negative 2.5, negative 1, and negative 4/10. They are now in order from least to greatest, because we know that negative rational numbers have an order that is opposite their absolute values. The absolute values of positive numbers always have the same order as the positive numbers themselves. Negative numbers have exactly the opposite order as their absolute values. The absolute values of numbers on the number line increase as you move away from 0 in either direction. The farther you are from 0, the greater the absolute value. Circling back around to the ICANN statements, I can show and explain that the order of positive numbers is the same as the order of their absolute value. Keep hitting this. If they are positive numbers, their absolute value will have the same order. If they are negative numbers, the order will be opposite for the absolute value. And hopefully you can explain and show after so many lessons that negative numbers are always less than positive numbers. That concludes Module 3, Lesson 12. Make sure you complete your problem set, your exit ticket. Make sure that you reach out to your teacher if you have questions or need assistance.